Here, the reaction 1 and 2 above are first order reactions. That means this R1 equal Ka concentration, R2 equals K2 P concentration. Initially, AP concentrations are same. When 12 seconds, A concentration is 2 times as the P concentration. A for a first order reaction, half-life is same. Constant. Half-life is constant. A after 1 half-life, the concentration become A by 2. After 2 half-lives, it become 4. It become 8. It becomes 16. Half-life. The method T1. Half-life is T1. See. T half वली denote करने time is T1. P gatto P concentration by 2, P concentration by 4, and P concentration by 8, and so on. 8, 16, like that. At the quarter, max 82. For methane T1 time. Here 2T1. Here 3T1. Then 4T1. Here T2, 2T2, 3T2. Here again 4T2, when P concentration 16. But it says when the concentration of A is 2P, A is 2P. A can, if you multiply this P by 8 into 2, then it will get the concentration. Because the initial concentration of both A and B are same, here the difference is 1 half-life. The difference is 1 half-life. Right? එතකොට A ගේ half-life ගාන n B ගේ half-lives n plus 1 ගානක් ගිහින් තියෙන්න ඕන. Right? Because මෙයා 5ක් යනකොට මෙයා 6ක් ගිහින් තියෙන්න ඕන. නැත්නම් මෙයා 1ක් යනකොට මෙයා 2ක් ගිහින් තියෙන්න ඕන. එතකොට නෙමෙයි A by 2 A by 4 මේක 2 වලින් වැඩි කරොත් A by 2 into 2 become A by 4 into 2 become A by 2 and so here we have simple logic. In a matter, I can write down NT1 must equal to N plus 1 T2. මේ දෙකම equal වෙන්න ඕන මොකේද? 12ට. එහෙනම් අපිට මේකට answers ගන්න පුළුවන් ඉලක්කම් දාලා මේකේ 2 3 දාලා බලමු. එයාට 2 දාලා එයාට 3 දැම්මොත් මේක 12 වෙන්න නම් n කීයද? n6 වෙනවා. නේද? Why? n into 2 equal 12. N equal 6. එහෙනම් make n equal 12 නම් මෙයාගේ ටයිම් එක 3ක් දාන්න. මෙයාගේ 3ක් දැම්මොත් n වෙන්න ඕනේ කීයද අපිට? 6 එන්න ඕනේ. මේකෙත් n must be 6. බලමු වෙනවද කියලා අපි. මේකට දැම්මොත් n plus 1 into 3 equal 12. එහෙනම් n plus 1 equal 4. n equals 3. n equal 3 වෙලා නේ. Rule end on 3 වෙලා. It cannot be. N has to be same. එතකොට n value එක different. ඒ කියන්නේ time එක 2 3 නෙවෙයි. Half lives are not 2 and 3. Then we try next version. 4 and 3. මං දානවා මෙයාට 4 මෙයාට 3. දාලා බලමු මෙන්ට same number එක එනවද? n into 4 equals 12, n equals 3. මෙතෙන්ට දානවා මම n plus 1 into 3 equals 12, n plus 1 equals 4, n equals 3. That is the correct answer. Then time is 4 and 3. නේද? අපි දැන් බලන්න ඕනේ a concentration must be, yeah. Oh, එතකොට the correct answer is second one. Why? When this goes n half lives, this must go n plus 1 number of half lives. Then only you get the correct answer. And the next question, contained in a vessel of volume of vessel is given as this much, and the number of moles of helium and oxygen and magnesium. Each of them will be in 0.01 moles. At this temperature, what will be the total pressure of the vessel if the magnesium is burned completely and the vessel is brought to the initial condition? Initially, if the pressure, no need that. You can write down first. Here, the magnesium will react with oxygen inside that, giving magnesium oxide. We have 0.1 moles of each. That means 0.101 of magnesium, 0.01 of oxygen. If you balance these two, is to 1 ratio between this magnesium and oxygen. Therefore, this is the initial amount, this is the reactant. 0.01 react 0.005 moles will be reacted by 2:1. If 0.01 is reacted, then the amount of oxygen reacted with that is 0.005. That's all. Then the remaining amount of gas, total of gas, at the end of reaction equals 0.01 of helium plus 0.005 of O2. In a total 0.015 moles. Now you can apply PV equal to NRT. P equals NRT over V. N is 0.015 moles into R 8.34 joule per Kelvin per mole into temperature 300 Kelvin divided by the volume is 4.157 decimeter cube into 10 to the power minus 3 meter cube. එතකොට අපිට එනවා 1 2. මෙයා යනවා න්यूमරේටර් එකට. එතකොට මෙයාට කැන්සල් වෙනවා. එතකොට අපිට ඉතුරු වෙන්නේ Here, 15 into 2 into 300. 15 into 2 into 300 is the answer. It can mean 30 into 300. This much of Pascal. 9,000 Pascal means 9 into 10 to the power 3. Pascal is the answer. Here you have to consider O5, which is the limiting reagent. In this case, the limiting reagent is magnesium. So magnesium will limit the reaction. Oxygen, we have excess. So oxygen is the excess reagent. And also we have that helium. Helium doesn't involve with the reaction. Well, helium does not involve with reaction because it is inert. So answer is the fourth one. In which of the following reaction is a compound with two asymmetric carbon atoms are formed? Addition of dilute alkali to this. See what happens here. CH2 double bond CH, CH2, another CH and OH will be given, but in this case you don't find any asymmetric carbon. Asymmetric carbon means carbon having 4 different groups attached. But in this case, no such. Next one, reacting. This with zinc Hg and concentrated HCl. If this react with zinc Hg concentrated HCl, that is called the Clemmensen reduction. Oh, you will get that the CH3, CH2, CH3 thrice. So even in this case, we will not find any asymmetric carbon. Next one, addition of HCl to aldehyde or ketone will result having OH and Cl on the same group. That means instead of this oxygen, oxygen will become OH minus and Cl will be attached to the other bond of this. So you will get in this case CH3CH2, C, O become OH, H is already available, and this becomes C, this is the Cn. So in this case, you have 4 different groups attached to this carbon. Therefore, it is the answer. This carbon is asymmetric. Why it is asymmetric? There are 4 different groups attached to that carbon. So it has different groups attached to it. So answer may be third one. When the following reaction is a compound with 2 asymmetric carbon atoms. 2 asymmetric carbon must be there. In this case, we have only 1 asymmetric carbon. Next one, acid addition of Br2 into this. Even in that case, you will not get such. CF3CH2. This is Br, this is hydrogen, and this We have two hydrogen already and another Br will be added. Only one asymmetric carbon. Then the answer must be the final one. Addition of NaOH to this will give us the aldol product. So easiest way of writing that aldol product is like this. We convert whatever the compound, you convert that into OH. First you turn that into OH, CH3, CH2, C, we have hydrogen here and this turned into OH. This hydrogen to turn that oxygen into OH will be given by another aldehyde molecule, but we alpha hydrogen. Alpha hydrogen of the alpha hydrogen means the hydrogen attached to the alpha carbon. Then you need to know what alpha carbon is. Alpha carbon is the carbon which is next to the aldehyde or ketone group. And here, what happens? This will be attached to that. May have attached, you know, methane. එතකොට අපිට මෙයාගේ හයිඩ්‍රජන් කෙනෙක් ඉන්නවා එක හයිඩ්‍රජන් කෙනෙක් මෙයාට දෙනවා ඊට පස්සේ මෙයාගේ තව තියෙනවා මොකද්ද CHO part එකක් කියන්නේ CH3. In this case we have compound with two chiral groups. One is this, the other one is this. Therefore, your answer is fifth one. Here, you are provided with 100 cubic centimeters of ether to extract the insecticide. X containing 100 cubic centimeters of water of an aqueous solution. If the volume of ether was used in two successive equal extractions, what is the percentage of X left in the aqueous solution at the end? The distribution coefficient is given as 18. Here, you are provided with 100 cubic centimeter of ether and water. Water layer, ether layer. I put WNE for different layers. It would be 100 cubic centimeters. 100 of an equal solution if the volume of ether was used in two successive extractions. Ether දාලා තියෙන්නේ 50-50. One we extract with 50 cubic centimeters of ether and then separate the layers and add another 50 cubic centimeter portion into the remaining amount of the solution and shake it well. And here 50-50. And I would say you have, they're asking about the amount as percentage. In some of the initially we have 100 units in aqueous layer. From aqueous layer, if X amount is migrated, you have X here. Normally, this insecticide is more dissolved in ether than in water. Normally, it has to be in that way. The concentration of that insecticide is X divided by 15 to 10 to the power minus 3. Here, 100 minus X over 0.1. Oh, I can put here as, okay. Volume 100 into 10 to the power minus 3. Then the KD. KD is equal to that insecticide X concentration in ether layer over X concentration in water layer or that W layer. KD is given as 18. Then 18 is equal to XC over XC is the X of 0.05. Here it is the 100 minus X over 0.1. From where did I get this 100? Because they are talking about percentage. I assume that the initial amount of insecticide in aqueous layer is 100 units. Maybe 100 moles, maybe 100 milligrams, maybe anything. Unit is 100. Then by simplifying this, you can get here 2 and 1. Then it will be 2x over 100 minus x. In the cross multiplication, it will give us 1800 minus 18x equals x. 2x. And then 20x equals 1800. And then x equals 90. Percentage is 90. So the remaining amount is 10. If we have 100, remaining amount is 10. Now we have 10 in the aqueous layer and y amount will be migrated to the ether layer. So 1/10 will remain. 1/10 means 1%. So the percentage is 1 for this answer. For this particular question, the answer is first part. Now in the second extraction, we have the aqueous layer. In that aqueous layer, we have 10. Why? 90 has been migrated. Without 100 minus x means 10. We have 10. And 50 ether. The amount migrated is y. Then you will get 18 equals 2y over 10 minus y. Then y equals 9 in this case. So 9. And then remaining amount is 10 minus y. 10 minus y equals 1. May 1 can out of 100. Therefore, percentage of remaining 1 over 100. 100 is the initial amount we took into 100. So it is 1%. So the answer is 1%. First one will be the answer. And Consider the following system in dynamic equilibrium. Wherever you get or whenever you get equilibrium system, we check first the physical states. Which of the following statement is correct about the probable changes in the above system when little amount of A is removed at constant temperature? What happens if you remove A? A gas, B gas. If we remove A, according to Le Chatelier principle, it tends to minimize the change. So system starts to increase the amount of A, means the reaction has to be reversed. Reaction has to be reversed, but it will adjust so as to Kp become the original value. Or Kp doesn't change because it is, if the temperature is constant. If the temperature changes, then only you can change the Kp. The rate of the forward reaction decreases. Definitely. Why? A concentration will decrease. Because of the decreasing of the A concentration, rate of the forward reaction will decrease. It has to be decreased. So A is correct. Why? Rate depends on the concentration. If the concentration is decreased, the rate will decrease. Rate of the backward reaction increase? No. Why? If the forward reaction decrease and reverse reaction increase, it will never become equilibrium. If decrease, both reaction has to be decreased. If increase, both reaction has to be increased. Initially, it may have 100, say, the rate is 100. Though because of the removal of A, if the rate become 880, then what happens? If the forward reaction is 80, still the reverse may be 100. Once we remove A, it will slowly become 80. Slowly it will decrease its rate to 80 and become equilibrium. That's what happened when you remove that. B is wrong. Value of Kp decrease never. Kp depends only on the temperature. Temperature may be constant. So they don't say anything about the temperature. So you can't say. It says at constant temperature. At constant temperature, Kp is constant. Then concentration be increased? Yes, definitely, because the reverse reaction take place in great extent. Then earlier, the reverse anyway, when A produce, B will also produce. Therefore, B concentration increase. A and D are correct. So the answer is fourth one. Answer is fourth one. Next one. Which of the following is correct about the complex compound? This is 4 amine, 1 nitrosyl, 1 chlorine, that chloride is still the charge is 2 minus. So the cobalt must be in +3 oxidation state. Why? Sulfate is 2 minus, then this must be 2 plus. 2 plus, when what is Cl minus is available. That means one oxidation state has been lost because of the presence of the Cl. Others are neutral. The cobalt must be in +3. Make another oxidation number of cobalt is +2. That is wrong. That is +3. First one, the coordination number of cobalt is 6. That is correct. Hey, we have 6 ligands attached to this. So 6 ligand means the coordination number. Coordination number is the number of ligands number of dentate, the dents, number of dents can number of bonds. Sometimes the number coordination number will equal to the number of ligands, but precisely it is given as the dents. How many dents? Dent එක කියලා කියන්නේ මොකද්ද? Dent is the lone pair, one lone pair, which ammonia will give one lone pair to cobalt, that is one dent. Polydentate ligand, monodentate ligand, and so on. The number of dents. First one is correct. Second one, it is colorless in aqueous solution. In this case, cobalt 3 plus. This is cobalt 3 plus solution. It is colored. Right? It must be colored. Because of the presence of this cobalt plus an ammonia, maybe yellow to brown color. It gives a white precipitate with an aqueous barium chloride. Here's why we have this ionic sulfate. Ionic sulfate is SO4 minus will react with the Ba2 plus, giving BaSO4, that is white precipitate. So it is correct. Again, A and C are correct. Fourth one is the answer.